Hello guys. Some of my customers, also my team members, ask me how to do the conversion between kilowatts hour and watts. So it's a little bit confusing. Um, if you really Google it, you will find out that the definition from Wiki is like this way, which I think is quite difficult to understand. Okay, so I'm trying to use the easier way to explain the difference and how to make the conversion. Okay, first let's forget about electricity things. Let's go to our daily life here. If you have a water tank, you have a hose, and you fill water inside. Let's say I have 10 seconds. 10 seconds later, and I fill the water with 10 liter. Okay, and we will know that the average water flow rate is 1 liter per second. Right? Okay, so let's change this concept a little bit into electricity. I have one machine, and you can understand the machine is like a hose, okay? And the electricity I use is like water. I fill into a tank. So 1 hours later, that is 3,600 seconds later, which is 1 hour, right? 1 hour later, my average power is 1,000 watts. But how much electricity I use, which is 1 kilowatts hour. All right. Please understand that watts is really the real-time power it use. Let's say it's in average power is every second in 1 hour. Is averagely it should be 1,000 watts, something like this. So it's describing is how to say that second, for example, second one, second 15, it's real-time power it use, how big it is. But the kilowatts hour is really the electricity it used. So let's say this is like water flow. This is like the water, right? I mean, how much water you have in the tank. So there's two different concepts. They cannot make a direct conversion. It really should involve in the time. So with the time, with the water flow speed, you get the final water you have here. All right. So let me explain a bit of the formulation how to change it. Okay. We have a power consumption in kilowatts hour is equal to average power in kilowatts unit. Pay attention, kilowatts. And multiple time, pay attention, is hour. You see, kilowatts hour is 1 kilowatts run in 1 hour the electricity you consumed. So that's the formulation. Pay attention a little bit. The tricky part is when you go to your computer or whatever your machine, and a lot of devices their writing is watts. It's not kilowatts. Okay. When you want to calculate the kilowatts hour here in this formulation, you really need to use kilowatts unit. So there's some change here. Also, time is hour, it's not a second. All right. For example, uh, here is here is one example. I calculate everything together for you. Okay. So let's say we have a 3,600 seconds running, right? That's 1 hour, right? And we have 1,000 watts here, right? So if we fill into this formulation, what do we do? First, we need to change the power into kilowatts. Average power in kilowatts is average power in watt divided with 1,000. 1,000, okay? So 1,000 watts divided with 1,000 is 1 kilowatts, right? And remember the time is 1 hour. So I mean, we already know this is 1 hour. So I have the calculator. It's 1 hour. But pay attention if it's like a 10 seconds or something. You need to change into the hour. Okay. For example, if people tell you, it's asking you that, hey, this machine for 200 seconds, how much power it use in kilowatts hour? Then you have to change the 200 seconds into the hour, right? So let's pay attention to this. The unit has to be correct. So that's why we have a 1 kilowatts Here's 1 kilowatts multiple 1 hour equal to 1 kilowatt hour. All right. So let's say, what if you have 2,000 watts this machine? Then you have a 2 kilowatts, and if 2 kilowatts device is running as 1 hour is 2 kilowatts hour, right? So what if I have a two 2,000 watts. I have one machine that is 2,000 watts, and it's around 2 hours. How much power I consume? It's like 2 kilowatts multiple 2 hours. That's 4 kilowatts hour, right? So that's the conversion. So again, please understand that this is like water flow things. This is like how much water you have here, you used here. Okay. There's one more knowledge here is for the power. Actually, we understand that how to say, ideally it should go like this way. I mean, it's a flat. It's flat. It's like 1,000 watts every second. It's like this. But the reality is the device's power consumption could be like this. Let's say it's averagely 1,000 watts. So when you are choosing some UPS power system, solar system for your devices, you need to consider this. So you need to reserve some margin here. For example, if this is my this is one machine, I'm choosing the UPS system for the machine, and I really will consider like a 1,500 watts here, or a little bigger, just to make some margin here to be safe. Okay. Okay, that's the concept here. So if you have any questions, just let me know. Okay, I'm here. Thank you.